Part 3 of your 5.2 notes, I think you're either going to love it or hate it. It's kind of puzzly, so if you like those other ones where they were kind of puzzly, then you might like these. You got to know how to do them, so please reach out to me with questions. So they say, suppose sine of alpha is 12/13 for a quadrant 2 angle alpha, and sine of beta is 3/5 for a quadrant 1 angle beta. Find the sine of alpha plus beta, the cosine of alpha plus beta, and the tangent of alpha plus beta. So let's start with the sine of alpha plus beta. Now we have a formula that I'm going to go ahead and write down that says the sine of alpha plus beta is equal to the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. And let's think about what we know. Well, we know that the sine of alpha is 12/13. And we know that the sine of beta is 3/5. So I'm plugging in pieces of my puzzle. So I need to figure out the cosine of beta, and I need to figure out the cosine of alpha. So I can go in whichever order I want. So off to the side here, I'm going to set up some triangles, because they say alpha is a quadrant 2 angle. So if there's alpha, its sine is 12/13, which means the opposite over hypotenuse is 12/13. So the adjacent, I can use the factor theorem, or if I already know that it's 5. But I am going to the left, so it is important. The fact that they say it's in quadrant 2 means that that 5 is negative. So the cosine of alpha, which is what I'm setting up, is adjacent over hypotenuse negative 5/13. So please make sure that you plug that into the right point. The cosine of alpha is over here, negative 5/13. And then if I want to know the sine of beta, or the cosine of beta, I can set up that beta is a quadrant 1 angle with a sine of 3/5. So an opposite of 3 and a hypotenuse of 5, which means its adjacent is 4. So the cosine of beta is adjacent over hypotenuse 4/5. So then I'm going to add together these two fractions. So 12 times 4 is 48. 13 times 5 is 65, and you can use your calculator by all means. The 5s do cancel, but I think I'd rather have the common denominators of 65 than have to get a common denominator back. So then negative 5 times 3 is negative 15. So 48 minus 15 is 33/65. And I would check if those could be reduced, and since they cannot, my final answer for the sine of alpha plus beta is equal to 33/65. Notice that I didn't need to know what the angle measures were at any point in time. So I actually have all my pieces of my puzzle, so the finding the cosine might go a little bit quicker. So the cosine of alpha plus beta, I'm going to write down my formula. The cosine of alpha plus beta is equal to cosine of alpha times cosine of beta minus sine of alpha times sine of beta. And so let's go back to this previous problem to find out my pieces. The cosine of alpha is negative 5/13. The cosine of beta is 4/5. Minus, because the formula is subtraction, the sine of alpha, which the problem tells me is 12/13, times the sine of beta, which the problem tells me is 3/5. And then I'm going to multiply. So negative 5 times 4 is negative 20. 13 times 5 is 65. Minus 13 times 5 is still 65. 12 times 3 is 36. So then negative 20 minus 36 is negative 56/65. And if I could reduce, then I would want to. That can't be reduced either. Okay, the tangent of alpha plus beta. So we have a formula that says the tangent of alpha plus beta is the tangent of alpha plus the tangent of beta over 1 minus the tangent of alpha times the tangent of beta. And you can 1000% use these triangles, find the tangent of alpha, etc., etc. But back in 4.2, we learned that tangent is equal to sine over cosine. So the tangent of alpha plus beta, in addition to being that formula that we just found, is also equal to the sine of alpha plus beta over the cosine of alpha plus beta. And now that we know both of these pieces, I think this is going to be an easier approach as opposed to using this formula. Not that we couldn't use that formula, but if I already know sine and cosine, I can find tangent a little bit quicker. So let's see, the sine of alpha plus beta is 33 over 65. And the cosine is negative 56 over 65. So I'm taking a fraction divided by a fraction. So another way that I can write this is 33 over 65 divided by negative 56 over 65. Well, dividing by a fraction is the same thing as multiplying by the reciprocal. And what you should notice when you multiply by the reciprocal, before you get your calculator out, that 65 and 65 cancel. So I'm left with 33 over 56 over negative 56. So let's just call the entire fraction negative. So negative 33 over 56 is the tangent. So I could use my tangent formula, or I could use sine divided by cosine.